Imagine a world teeming with data, billions of devices interconnected. Every click, every swipe, every interaction generates information. This is the reality of modern systems. These systems are complex. They're intricate webs of services, constantly communicating. They need to be robust, reliable, and above all, understandable. Without clarity, these systems devolve into chaos. Troubleshooting becomes a nightmare. Performance suffers. Innovation is stifled. This is where observable architecture comes in. It's the difference between a cacophony of noise and a beautifully orchestrated symphony. Let's take a real-world example. Black Friday 2023, millions shopping online. Stripe, the payment processing giant, faced an unprecedented surge. 100 million transactions per hour. That's the scale Stripe had to handle. And they did it flawlessly. No major incidents. How? Stripe's secret was their observable architecture. They didn't just react to problems, they anticipated them. They had complete visibility into their system's behavior. This is the power of observability. It's about knowing the pulse of your system. It's about understanding its every beat, every rhythm. Traditional architectures often operate like black boxes. You know the inputs, you hope for the desired outputs, but what happens in between remains a mystery until something goes wrong. Observable architecture flips the script. It champions transparency. It provides a clear, real-time view into the inner workings of your system. Think of it as your system's own personal X-ray vision. This transparency is achieved by instrumenting your system to emit valuable data metrics, logs, and traces. These become the vital signs of your application, constantly monitored and analyzed. But observability isn't just about collecting data. It's about using that data to gain actionable insights. It's about understanding the why behind the what. In a reactive world, you fix problems as they arise. This can lead to a never-ending cycle of firefighting with no time for proactive improvements. Observable architectures empower you to shift from reactive to proactive. By constantly monitoring key indicators, you can identify potential issues before they escalate into major outages. Imagine detecting a slight increase in latency in a critical service. In a traditional system, this might go unnoticed until it snowballs into a full-blown outage. But with observability, this subtle change becomes an early warning sign. You can investigate, diagnose, and rectify the issue before it impacts your users. Section 3, Pillars of Clarity. To build a truly observable system, we rely on 4 fundamental patterns. These pillars of clarity guide our instrumentation and analysis, providing a comprehensive view of our system's health. First, we have the Telemetry Mesh. This pattern emphasizes the importance of collecting comprehensive telemetry data from all parts of the system. Think of it as the nervous system relaying vital signs from every corner. Next, the event backbone serves as the central nervous system, collecting and distributing events happening within our system. These events provide a chronological log of actions and changes, enabling us to trace the flow of information. The state tracker acts as the system's memory, providing a snapshot of the current state of various components. This allows us to understand the system's configuration and identify any inconsistencies or anomalies. Section 1. The Telemetry Mesh. Imagine your system as a vast network of interconnected services. Each service a vital organ performing its role in the larger organism. Monitor the heartbeat, temperature, and energy levels of each service in real time. That's the power of the Telemetry Mesh. Instrument your services to emit telemetry data, metrics, logs, and traces. Metrics provide quantitative measurements. Logs capture specific actions and outcomes. Traces map requests, journeys, and reveal performance bottlenecks. Gain visibility into your system's operational state. Identify performance issues and troubleshoot errors. It's like having microscopic observers reporting on system health. Integrate telemetry libraries into your services and configure them to collect and transmit data. The platform aggregates, analyzes, and visualizes the data, providing actionable insights. Section 2. Writing the event. Backbone in your system, events are constantly unfolding. Orders placed, payments processed, messages exchanged. The event backbone pattern captures these stories. It acts as a central hub for publishing, subscribing, and processing events. This could be a message queue, event streaming platform, or event bus. Gain real-time insights, track progress, and detect anomalies. The event backbone is invaluable for debugging and auditing. Imagine solving a mystery without knowing the initial conditions. The state tracker captures and tracks system states. It records and queries the state of system entities. Maintain a historical record to trace issues. Understand component interactions and ensure system health. In a complex distributed system, failures are inevitable. The key is to detect and mitigate failures quickly. The health mesh acts as a vigilant guardian. Embedding health checks provides real-time status. These checks cover various health aspects. Aggregated results offer a comprehensive view. Quickly identify and correct failing services. Now that we've explored the 4 pillars of observability, let's implement these patterns in a real-world scenario. Imagine building a payment processing microservice. It handles payment requests, validates information, and communicates with external gateways. We'll use Flask or FastAPI for observability. Create a basic service structure, defining endpoints for payment requests. Initialize a tracer object with open telemetry to capture metrics, logs, and traces. With the basic structure in place, let's add telemetry to our payment processing endpoint. Inside the function, we'll use the object to create a new span. A span represents a single unit of work within a trace, capturing information about the operation's duration, status, and any associated attributes. We'll name our span to reflect the specific action being performed. Within the span's context, we'll add attributes to capture relevant payment information such as the payment amount and type. These attributes will provide valuable context when analyzing our telemetry data later. App.root post-process payment, methods sign post, def process payment, media group animated visualization of telemetry data analysis, screen recording of function with span attributes, stock with distribute. Equally with tracer, start as current span process payment. As span try payment data came request get JSON, span.set, attribute, payment amount, payment data.get amount, span.set, attribute, payment.type, payment data get type, span.set, status on error, stay, return, payment processing fail. In a microservice architecture, services need to communicate effectively to coordinate tasks and share information. Events provide a powerful mechanism for asynchronous, loosely coupled communication. Let's say our payment processing service needs to notify other parts of the system when a payment is successfully processed. Instead of making direct synchronous calls to other services, we can publish an event to an event bus. Other services interested in this event, such as an order management service or a notification service, can then subscribe to the event bus and react accordingly. This event-driven approach promotes loose coupling, allowing services to evolve independently without tight dependencies. From your event suck library, import event bus, app route conch process payment, methods chain post def process payment, media group animated diagram of loosely coupled microservices, visualization of independent evolution of services, coding example of event-driven architecture promoting loose coupling, stock or distribute equally, event bus publish payment processed, payment ID. From online retail to cloud computing, Amazon handles a staggering volume of transactions and data every second. Their success hinges on a robust, scalable, and highly observable architecture. Let's delve into the intricacies of their approach. Imagine a network of millions of interconnected microservices, each handling specific tasks, communicating seamlessly and collectively powering Amazon's vast ecosystem. This distributed system demands a high degree of observability. They leverage service meshes to manage communication between services, implement sophisticated observability pipelines to collect and analyze telemetry data, and prioritize proactive monitoring to maintain system health and performance. By embracing these patterns, Amazon gains unparalleled visibility into their system's behavior, enabling them to detect and remediate issues before they impact customers, optimize performance for efficiency and cost savings, and continuously innovate with confidence. Managing communication in distributed systems can be complex. A service mesh manages traffic, enhances security, and provides observability. Amazon uses Istio to manage communication. Istio's sidecar proxies handle traffic routing and load balancing. They collect telemetry data for observability, capturing metrics like request rates and latency. Istio enables distributed tracing to identify bottlenecks. Section 3, the Observability Pipeline. Collecting telemetry data is only the first step towards observability. Amazon has built a sophisticated observability pipeline to process, analyze, and visualize this data, transforming raw metrics, logs, and traces into actionable insights. This pipeline involves multiple stages. First, telemetry data from various sources, including Istio, sidecar proxies, application logs, and custom instrumentation, is aggregated into a central location, often a distributed tracing system or a time series database. Next, the data is enriched with additional context, such as service names, deployment environments, and business relevant metadata. This enrichment makes it easier to filter, search, and analyze the data effectively. Finally, the processed data is visualized through dashboards, alerts, and automated reports, providing engineers with real-time insights into the system's health, performance, and user behavior. This enables proactive monitoring, rapid incident response, and data-driven decision-making. Section 1. Architecting for Observability. Building an observable architecture isn't about bolting on tools after the fact. It's about baking observability into the very DNA of your system. Make conscious design choices that prioritize transparency and insight. Embrace a modular, loosely coupled architecture like microservices. Isolate components to monitor and troubleshoot individual services. Adopt a consistent approach to instrumentation. Use a centralized telemetry library for standardized data collection. This simplifies analysis and avoids a fragmented view of your system. Implement automated deployment pipelines with observability checks. Ensure new code releases don't introduce blind spots. Section 2. The Observability Layer. A robust observability layer helps manage and optimize your system by making sense of telemetry data. It acts as a command center, providing tools and insights. Your observability platform is at its heart. Choose from open source and commercial options, each with unique features. Ensure it offers data collection, storage, visualization, and alerting. The right platform empowers your team with actionable insights. Section 1. The future is observable. We've journeyed through observable architecture from principles to real-world implementations. Companies like Stripe and Amazon leverage observability for scale and performance. But this is just the beginning. As systems grow complex, the need for observability will increase. It's a necessity for modern applications. The journey starts with a shift in mindset. Embrace transparency and prioritize instrumentation. Ready to start your observability journey? Download our architecture blueprint kit today. Visit observable.future/architecture. The future is observable and it's in your hands.